uncharted territories of the universe. Why Alpha Centauri? Why not a different star system, one perhaps less challenging to reach? The universe is vast, filled with countless stars and planets, each with its own unique characteristics and potential for discovery. The answer lies in its proximity. Alpha Centauri is not just another star system, it is our closest neighbor in the cosmic expanse. At just over 4 light-years away, Alpha Centauri is the closest star system to our own. This proximity makes it an enticing target for our first interstellar journey. While 4 light-years may seem like an insurmountable distance, it's practically next door in the grand scheme of the universe. To put it into perspective, the Voyager 1 spacecraft, which has been traveling for over 40 years, is still less than a light day away from Earth. To put it into perspective, the Milky Way galaxy, our home galaxy, is estimated to be over 100,000 light-years across. This means that Alpha Centauri is just a tiny hop compared to the vast distances that span our galaxy. Alpha Centauri's proximity makes it the most logical target for interstellar travel. It represents a stepping stone, a first leap into the broader universe beyond our solar system. It offers us the best chance to study a star system up close, to unravel the mysteries of star formation, and to search for signs of life beyond Earth. The knowledge we gain from such a mission could revolutionize our understanding of the cosmos. But distance isn't the only factor that makes Alpha Centauri so intriguing. The system itself is a treasure trove of astronomical wonders. The system itself is fascinating, consisting of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Each of these stars has its own unique characteristics and potential for hosting planets. Proxima Centauri, a red dwarf star, is known to host at least 2 planets, one of which resides within the star's habitable zone, the region where conditions might be just right for liquid water to exist on the surface. This makes it a prime candidate in the search for extraterrestrial life. The possibility of finding a world capable of supporting life so close to home is a powerful motivator, driving us to develop the technologies needed to bridge the interstellar divide. The advancements in propulsion, communication, and life support systems required for such a mission could have far-reaching benefits for humanity. Alpha Centauri is more than a destination. It's a cosmic invitation to explore the wonders of our universe. It challenges us to push the boundaries of what is possible, to dream bigger, and to reach further than ever before. Throughout history, humanity has always been driven by the desire to explore the unknown. From the first voyages across uncharted seas to the landing on the moon, each step has been fueled by curiosity and the quest for knowledge. The journey to Alpha Centauri represents the next great adventure in this ongoing saga. It is a mission that will require international collaboration, cutting-edge technology, and the indomitable spirit of exploration. Scientists and engineers around the world are already working on the technologies that will make this journey possible. From advanced propulsion systems like ion drives and solar sails, to the development of autonomous spacecraft capable of making the long journey, the groundwork is being laid for humanity's first interstellar voyage. Imagine a future where a spacecraft built by the combined efforts of humanity reaches Alpha Centauri. The data it sends back could reveal new worlds, new possibilities, and perhaps even new forms of life. It could pave the way for future missions, including the possibility of human colonization of exoplanets. Alpha Centauri beckons us with the promise of discovery and the allure of the unknown. It is a reminder that, despite the challenges, the spirit of exploration is an intrinsic part of what it means to be human. As we stand on the brink of this new frontier, we are reminded that the journey to Alpha Centauri is not just about reaching a distant star system. It is about pushing the boundaries of our knowledge, expanding our horizons, and embracing the infinite possibilities that the universe has to offer. The challenges of interstellar travel are immense. The vastness of space presents a formidable barrier, with distances so great that even the fastest spacecraft we have today would take tens of thousands of years to reach the nearest stars. The sheer scale of the cosmos is both awe-inspiring and daunting, making the dream of interstellar travel seem almost impossible with our current technology. Traditional rocket propulsion, while suitable for journeys within our solar system, falls short when it comes to traversing the vast distances between stars. Rockets rely on chemical propulsion, which is effective for short trips to the Moon or Mars, but becomes impractical for interstellar voyages. The amount of fuel required would be astronomical, and the speeds achievable are simply too slow for meaningful exploration beyond our solar neighborhood. To reach Alpha Centauri within a human lifetime, we need a radical new approach, a paradigm shift in space travel technology. This means thinking beyond conventional rockets and exploring innovative propulsion methods that can achieve much higher speeds. Scientists and engineers are now looking at concepts that once seemed like science fiction, such as antimatter engines, warp drives, and light sails, to make interstellar travel a reality. Enter Breakthrough Starshot, an ambitious project that aims to do just that. This initiative is not just about dreaming big, it's about taking concrete steps towards making interstellar travel possible. By leveraging cutting-edge technology and innovative thinking, Breakthrough Starshot seeks to overcome the limitations of traditional propulsion methods and open up new frontiers in space exploration. The brainchild of physicist Stephen Hawking and entrepreneur Yuri Milner, Breakthrough Starshot envisions sending a fleet of tiny, gram-scale spacecraft to Alpha Centauri, propelled by the most powerful force in the universe, light itself. These miniature spacecraft, known as starships, would be equipped with light sails that harness the momentum of photons to achieve unprecedented speeds. The concept behind Breakthrough Starshot is both elegant and audacious. It combines the simplicity of light propulsion with the complexity of advanced engineering to create a feasible path to the stars. The light sails, made from ultra-thin, highly reflective materials, would capture the energy from powerful laser beams, propelling the starships forward at a significant fraction of the speed of light. Each spacecraft, known as a starship, would be equipped with a light sail, a thin, reflective sail that acts like a cosmic windsock. These sails are designed to catch the light from Earth-based lasers, converting the energy into thrust. The technology behind these sails is a marvel of modern engineering, requiring materials that are both incredibly light and exceptionally strong. Powerful lasers based on Earth would then fire beams of light at these sails, imparting momentum and accelerating the starships to a significant fraction of the speed of light. These laser arrays would need to be incredibly precise, capable of maintaining a steady beam over vast distances to ensure the starships stay on course. The coordination and control required for this system are immense, but the potential rewards are even greater. At these incredible speeds, a journey to Alpha Centauri could be completed in just a few decades, short enough for us to receive data back within a human lifetime. This means that the dream of exploring another star system could become a reality within the next generation. The data sent back by these tiny spacecraft could revolutionize our understanding of the universe and our place within it. Breakthrough Starshot represents a bold vision for the future of space exploration, one where light itself becomes the engine that carries us to the stars. This project is a testament to human ingenuity and our unyielding desire to explore the unknown. By pushing the boundaries of what is possible, Breakthrough Starshot is paving the way for a new era of interstellar travel, where the stars are no longer out of reach but within our today. Our closest stellar neighbor, Alpha Centauri, holds a special allure. This star system, a mere 4.37 light-years away, is home to Proxima Centauri. Proxima Centauri is a red dwarf star that may host potentially habitable planets. Imagine standing on the surface of an alien world, gazing back at our own sun as a distant star. The thought of reaching another star system within a human lifetime was once unthinkable. However, technological advancements and a bold vision are rapidly turning science fiction into a tangible reality. Alpha Centauri is no longer an unreachable dream, it's a destination. Enter Breakthrough Starshot, a groundbreaking initiative aimed at propelling humanity to the stars. This ambitious project seeks to develop a fleet of ultralight spacecraft, no larger than a microchip. These tiny explorers will journey to Alpha Centauri at a fraction of the speed of light. The concept might sound like something out of Star Trek, but it's grounded in real science. Breakthrough Starshot leverages cutting-edge technology and innovative thinking. It offers a glimpse into the future of space travel. The journey to Alpha Centauri will be unlike anything we've attempted before. Central to Breakthrough Starshot's vision is the ingenious use of light sails. These wafer-thin sails, propelled by powerful lasers, harness the momentum of photons to achieve unprecedented speeds. Imagine a sail catching the wind, but instead of wind, it's pure light pushing the spacecraft forward. This revolutionary propulsion system allows the spacecraft to accelerate to a significant fraction of the speed of light. The journey to Alpha Centauri, which would take tens of thousands of years with conventional rockets, could be completed within a few decades. This technology is key to unlocking interstellar travel. Section 5. Making the impossible possible. The feasibility of interstellar travel. While the concept of interstellar travel may seem daunting, recent advancements in various fields make it increasingly feasible. Nanotechnology enables us to create smaller, more efficient spacecraft. Advances in laser technology provide the power needed to propel these miniature explorers across vast distances. The challenges are significant but not insurmountable. Already, researchers are making significant progress in developing the necessary technologies. With continued investment and global collaboration, the dream of reaching Alpha Centauri within this century is well within our grasp. Section 6. The challenges of a human journey. Time, distance, and the fragility of life. While sending tiny probes to Alpha Centauri is a monumental task, the challenges of human interstellar travel are even more complex. The vast distances involved mean that even at the speed of light, it would take over 4 years to reach our nearest stellar neighbor. This is a journey that requires not just advanced technology, but also a deep understanding of the human condition. The human body is fragile. Unlike machines, we are susceptible to a myriad of environmental factors that can affect our health and well-being. Space is an unforgiving environment, and the human body is not naturally equipped to handle its harsh conditions. Long-duration space travel poses significant risks, including exposure to radiation, muscle and bone atrophy, and the effects of prolonged weightlessness. Astronauts must exercise rigorously to maintain their physical health, but even with these precautions, the toll on the body is substantial. Additionally, the psychological effects of confinement and isolation cannot be underestimated. Being in a confined space for extended periods can lead to mental health challenges, including depression and anxiety. The lack of social interaction and the monotony of the environment can exacerbate these issues. One solution could be the development of generation ships. These are massive vessels designed to sustain human life over multiple generations, effectively creating a self-sustaining ecosystem in space. These massive vessels would carry entire communities on multi-generational journeys to the stars. Families would live, work, and grow old on these ships, passing the torch to the next generation until the destination is finally reached. While this concept presents its own set of challenges, such as maintaining social order and ensuring the health and well-being of all inhabitants, it highlights the lengths to which humanity is willing to go to explore the cosmos. The dream of reaching the stars is a testament to our enduring spirit of exploration and our desire to push the boundaries of what is possible. Section 7. Robotic Pioneers, sending AI scouts to Alpha Centauri. Before we send humans to the stars, it's prudent to first dispatch robotic emissaries. AI-driven probes equipped with advanced sensors and communication systems can serve as our eyes and ears in Alpha Centauri. They can explore the system, gather data, and pave the way for future human missions. These robotic explorers, unburdened by the limitations of the human body, can travel faster and endure the harsh conditions of interstellar space. The data they collect will be invaluable in preparing for future human missions to Alpha Centauri. They are the pioneers of a new era of exploration. Section 8, Communication Across the Abyss. Quantum entanglement and the future of data transfer. Communication across interstellar distances poses a significant hurdle. Traditional radio waves would take years to travel between Earth and Alpha Centauri. This delay makes real-time communication impossible. However, the emerging field of quantum communication offers a potential solution. Quantum entanglement, a phenomenon where two particles are linked regardless of distance, could enable instantaneous communication across light years. Though still in its infancy, this revolutionary technology holds the key to overcoming the communication barrier in interstellar travel. Section 9. Reaching for the Stars. A new era of exploration by 2100. The journey to Alpha Centauri by 2100 is not merely a possibility, it's an inevitability. As we stand on the brink of this monumental leap, we are reminded of the countless generations who have gazed at the night sky, dreaming of what lies beyond. Now, with the dawn of advanced propulsion systems and sustainable life support technologies, those dreams are within our grasp. Driven by our insatiable curiosity and fueled by technological advancements, humanity is on the cusp of an unprecedented era of interstellar exploration. Our laboratories are buzzing with innovation, from quantum computing to artificial intelligence, all converging to make this journey possible. The collaboration between nations and private enterprises has never been stronger, as we unite with a common goal, to reach the stars. The challenges are significant but not insurmountable. Navigating through asteroid fields, ensuring the safety of our astronauts, and maintaining communication over vast distances are just a few of the hurdles we must overcome. Yet, with each challenge, we grow stronger, more resilient, and more determined. This journey will test our limits, push the boundaries of science, and redefine our place in the universe. Every experiment conducted in the vacuum of space, every new planet approached, brings us closer to understanding the cosmos and our role within it. The knowledge we gain will not only benefit those who venture into the stars, but will also have profound implications for life on Earth. It's a journey worth taking, for it holds the promise of unlocking profound discoveries and ushering in a new chapter in human history. The stars await us. Let the adventure begin. As we embark on this voyage, we carry with us the hopes and dreams of all humanity, ready to explore, to learn, and to grow. The universe is vast and our journey is just beginning. Together, we will reach for the stars and beyond, forging a future where the boundaries of our world are limited only by our imagination. A cosmic dream, reaching for Alpha Centauri. This is not just a journey through space. It is a journey through our collective imagination, a testament to human ingenuity and the relentless pursuit of knowledge. Alpha Centauri, the closest star system to our own, has long been a beacon for dreamers and scientists alike. It represents the next great leap for humanity, a step into the vast unknown that lies beyond our solar system. By the year 2150, we aim to reach Alpha Centauri. This ambitious goal is the culmination of decades of research, innovation, and the unyielding human spirit. Our journey will begin with the launch of a state-of-the-art spacecraft designed to withstand the rigors of interstellar travel. As we leave Earth behind, we carry with us the hopes and dreams of countless generations who have looked up at the stars and wondered what lies beyond. This is a bold ambition. It requires not only advanced technology but also the courage to face the unknown. Our spacecraft is equipped with the latest advancements in propulsion, navigation, and life support systems, ensuring that our crew can survive and thrive in the harsh environment of space. Every detail has been meticulously planned, from the design of the spacecraft to the training of the astronauts who will embark on this historic mission. It's a testament to our curiosity. The desire to explore and understand the universe is deeply ingrained in the human spirit. As our astronauts gaze out of the spaceship windows, they are not just looking at the stars, they are looking at the future of humanity. Back on Earth, people from all walks of life will be watching, united in their fascination and support for this incredible journey. We are driven to explore. The vastness of space is both daunting and exhilarating, filled with endless possibilities and challenges. Our mission to Alpha Centauri is a testament to our determination to push the boundaries of what is possible. As our spacecraft moves through the stars, our astronauts will conduct experiments, gather data, and perform spacewalks, all in the name of advancing human knowledge. Alpha Centauri is a star system. It consists of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. This system has intrigued astronomers for centuries, and now we have the opportunity to explore it up close. The mysteries of Alpha Centauri beckon us, promising new discoveries and insights into the nature of the universe. It beckons us with its mysteries. What secrets does Alpha Centauri hold? Are there planets orbiting these stars that could potentially harbor life? These questions drive our mission, fueling our desire to explore and understand. As our spaceship approaches this distant star system, we are filled with a sense of wonder and anticipation. This journey will test our limits. The path to Alpha Centauri is fraught with challenges, from navigating through asteroid fields to dealing with the effects of long-term space travel on the human body. Our mission control team will work tirelessly to ensure the safety and success of the mission, constantly monitoring the spacecraft and providing support to the crew. It will redefine what is possible. The technology developed for this mission will have far-reaching implications, not just for space travel but for life on Earth as well. From advancements in propulsion systems to new medical technologies, the innovations born from our journey to Alpha Centauri will benefit humanity in countless ways. This is not just a mission. It is a defining moment for humanity, a testament to our ability to dream big and achieve the impossible. The astronauts who embark on this journey are not just explorers, they are pioneers, blazing a trail for future generations to follow. It's a defining moment for humanity. As we watch the spaceship depart from Earth, we are reminded of the incredible progress we have made as a species. This mission represents the culmination of centuries of scientific discovery and technological innovation, and it is a testament to what we can achieve when we work together towards a common goal. We will venture beyond our solar system. This journey marks the beginning of a new era of exploration, one that will take us to the farthest reaches of the universe. As our spacecraft leaves the solar system behind, we are filled with a sense of awe and excitement for the adventures that lie ahead. We will carry the hopes and dreams of generations. This mission is not just about reaching Alpha Centauri, it is about inspiring future generations to dream big and pursue their own goals. As children gaze up at the stars, they will see a future filled with endless possibilities, and they will know that anything is possible if they dare to dream. This journey will inspire us. It will remind us of the power of human ingenuity and the importance of pushing the boundaries of what is possible. As we watch the spaceship soar through space, we are filled with a sense of pride and wonder, knowing that we are part of something truly extraordinary. It will unite us in a common goal. This mission to Alpha Centauri is a testament to what we can achieve when we come together as a global community. People from all corners of the Earth will be watching, united in their support and excitement for this incredible journey. Together we will reach for the stars and explore the unknown, driven by our shared curiosity and determination. The significance of Alpha Centauri, our interstellar neighbor, cannot be overstated. This star system has captured the imagination of scientists and space enthusiasts alike for decades. Alpha Centauri is the closest star system to our own, making it a prime candidate for exploration and study. Its proximity offers a unique opportunity to understand more about our cosmic neighborhood. It is located 4.37 light-years away from Earth. While this may seem like an insurmountable distance, in the grand scheme of the universe, it is relatively close. This is a vast distance indeed, but when we consider the scale of the Milky Way galaxy, Alpha Centauri is practically in our backyard. On a cosmic scale, Alpha Centauri's proximity is a tantalizing reminder of the vastness of space and the potential for discovery just beyond our reach. The Alpha Centauri system consists of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. This trinary star system is a fascinating subject of study. 2 of these stars, Alpha Centauri A and B, are similar to our Sun in size and brightness, making them particularly interesting for comparative studies. The 3rd star, Proxima Centauri, is a red dwarf. Red dwarfs are the most common type of star in the Milky Way, but Proxima Centauri's proximity makes it special. This star system is of great interest to scientists because it may harbor planets. The possibility of finding exoplanets in the habitable zone of these stars is a thrilling prospect. Some of these planets might be habitable, meaning they could have the right conditions to support life as we know it. This raises exciting possibilities for future exploration. Imagine finding life beyond Earth. The discovery of even microbial life on a planet in the Alpha Centauri system would be a monumental achievement. Such a discovery would be profound, sparking new questions and potentially providing answers to age-old questions about our place in the universe. It would fundamentally change our understanding of the universe, opening up new avenues of scientific inquiry and expanding our horizons in ways we can only begin to imagine. Technological leaps are the cornerstone of our journey to the stars, building the ship of tomorrow. This endeavor is not just about creating a vessel, it's about pushing the boundaries of human ingenuity and engineering. Reaching Alpha Centauri, our nearest star system, is a monumental challenge. It requires technological advancements that are currently beyond our reach but not beyond our imagination. We need to develop new propulsion systems that can carry us across the vast distances of space. These systems must be revolutionary, capable of harnessing energy in ways we've never done before. These propulsion systems must be both efficient and powerful, able to sustain long-duration missions without compromising on speed or safety. To make this journey feasible, we need to travel at a significant fraction of the speed of light. This means overcoming immense technical challenges and breaking new ground in physics and engineering. We also need to create life support systems that can sustain human life for decades. These systems must be robust, reliable, and capable of providing all the necessities of life in the harsh environment of space. Radiation shielding is crucial for protecting the crew from harmful cosmic rays and other space radiation. This technology must be advanced enough to ensure the safety and health of the crew over long periods. It will protect the crew from harmful cosmic rays, which are a significant threat in deep space. Effective shielding will be a key component of our spacecraft design. This mission will push the boundaries of engineering and science. It will require unprecedented levels of collaboration and innovation from the brightest minds across the globe. The innovations developed for this mission will not only benefit space exploration but also have far-reaching impacts on technology and society. From advanced materials to new energy sources, the benefits will be felt in many areas of our daily lives. The speed of light and us, a dance with time and distance. The speed of light is the ultimate speed limit. It's about 299,792 kilometers per second. Even at this speed, the journey to Alpha Centauri would take years. Time dilation becomes a factor. Time slows down for objects traveling at high speeds. This means that time would pass differently for the crew. They would age slower than people on Earth. This is a mind-bending concept. It's one of the many fascinating aspects of interstellar travel. Section 5. Breakthrough Starshot, riding beams of light to the stars. Breakthrough Starshot is a promising concept. It proposes using lasers to propel tiny spacecraft. These spacecraft are called starships. They would be equipped with cameras and sensors. They would travel at 20% the speed of light. This would reduce the travel time to Alpha Centauri. It would take about 20 years. This is still a significant amount of time, but it's within the realm of possibility. Breakthrough Starshot is a bold idea. It captures the imagination. Section 6. The human element. Courage, curiosity, and the unknown. The journey to Alpha Centauri will be physically demanding. It will also be psychologically challenging. The crew will face isolation and confinement. They will be pioneers. They will be venturing into the unknown. Their courage and resilience will be tested. They will need to work together. They will need to support each other. This mission will be a testament to the human spirit. It will show our ability to overcome adversity. Section 7. Ethical considerations. Our responsibility as cosmic explorers. As we venture into space, we must consider the ethical implications. We must avoid contaminating other planets. We must respect any life we may encounter. We must act responsibly. We are ambassadors of Earth. We represent all of humanity. Our actions will have consequences. We must proceed with caution and respect. We must be mindful of our place in the cosmos. Section 8. A new perspective, redefining humanity's place in the universe. The journey to Alpha Centauri will be transformative. It will change our perspective. It will make us see ourselves differently. We will no longer be confined to Earth. We will be a spacefaring civilization. This will have profound philosophical implications. It will challenge our assumptions about our place in the universe. It will force us to confront the big questions. What is our purpose? Are we alone? Section 9. Conclusion: a giant leap for humankind. The journey to Alpha Centauri is a daunting challenge, but it's also an incredible opportunity. It's a chance to explore the universe. It's a chance to learn more about ourselves. It's a chance to create a better future. This is a journey for all of humanity. It's a journey that will inspire generations to come. It's a giant leap for humankind. Space, the final frontier, a vast expanse that stretches beyond our imagination, filled with wonders and mysteries yet to be uncovered. For millennia, humans have gazed at the stars. We pondered their mysteries, wondering what lies beyond our world. The night sky has always been a source of inspiration and curiosity, a canvas of twinkling lights that beckon us to explore. We dreamed of reaching them. The idea of traveling to the stars has fueled our imaginations and driven us to push the boundaries of what is possible. From the earliest rocketry experiments to the sophisticated space missions of today, our desire to explore the cosmos has never waned. Each twinkling point of light, a distant sun. These stars, scattered across the universe, are not just points of light but potential worlds, each with its own story to tell. They are beacons of hope, guiding us on our journey to understand the universe, a potential cradle of life. The discovery of exoplanets has opened up new possibilities, suggesting that life could exist beyond Earth. These distant worlds, with their diverse landscapes and environments, ignite our imagination and drive our quest for knowledge. The desire to explore is embedded in our DNA. It is a fundamental part of who we are as a species. From the earliest explorers who crossed oceans to the astronauts who venture into space, the spirit of exploration is a defining characteristic of humanity. To seek new horizons, to push the boundaries of knowledge. Our journey into space is not just about reaching new destinations, but about expanding our understanding of the universe and our place within it. Each mission, each discovery brings us one step closer to unraveling the mysteries of the cosmos. The dream of interstellar travel, once relegated to science fiction, became the ultimate goal. Stories of space travel have captivated our imaginations for generations, inspiring scientists and engineers to turn fiction into reality. The vision of traveling to distant stars has driven technological advancements and sparked a new era of exploration. For centuries, the stars seemed impossibly distant. The vastness of space, the immense distances between stars, made the idea of interstellar travel seem like a distant dream. Yet our determination to reach the stars never wavered. The vast gulf between our solar system and even the nearest star, Alpha Centauri, felt insurmountable. The challenges of interstellar travel, from the immense distances to the technological hurdles, seemed overwhelming, but with each passing year we made progress, inching closer to our goal. Yet we dared to dream. Visionaries and dreamers, scientists and engineers, all worked together to turn the impossible into the possible. Their unwavering belief in the potential of space travel fueled their efforts and inspired generations to come. Scientists and engineers worked tirelessly. They dedicated their lives to solving the complex problems of space travel, developing new technologies and pushing the boundaries of what we thought was possible. Their efforts laid the foundation for the future of interstellar exploration. They pushed the boundaries of technology. From advanced propulsion systems to innovative spacecraft designs, each breakthrough brought us closer to the stars. The relentless pursuit of knowledge and innovation drove the development of new technologies that would make interstellar travel a reality. They sought a way to bridge the chasm between the stars. The challenge was immense, but the potential rewards were even greater. The dream of reaching distant stars drove countless hours of research, experimentation, and collaboration. The dream fueled countless hours of research, innovation, and a spirit of unwavering determination. The collective efforts of scientists, engineers, and visionaries brought us closer to realizing the dream of interstellar travel. In the 21st century, the pace of progress accelerated. Advances in technology, from artificial intelligence to quantum computing, revolutionized our approach to space travel. The rapid development of new materials and propulsion systems brought us closer to achieving our goal. Breakthroughs in physics, engineering, and material science brought interstellar travel within reach. The development of new propulsion systems capable of reaching unprecedented speeds made the dream of traveling to distant stars a tangible possibility. The dream of reaching Alpha Centauri was no longer a distant fantasy. It became a goal within our grasp, a challenge that we were ready to embrace. The vision of traveling to another star system inspired a new generation of explorers and scientists. It was a tangible goal, a challenge that humanity was finally ready to embrace. The successful missions and technological advancements of the 21st century laid the groundwork for future interstellar travel. The stars were calling, and we were ready to answer. With each step forward, we moved closer to realizing our dream of exploring the cosmos. The journey to the stars had begun, and humanity was poised to take its place among the stars. The key to interstellar travel lay in harnessing the power of the stars themselves. Fusion power, the energy source of the sun, held the promise of near-limitless energy. This technology was crucial for propelling a spacecraft across the vast interstellar distances. For decades, scientists struggled to create a stable and controlled fusion reaction. The challenges were immense, but the potential rewards were even greater. Then, a breakthrough. Researchers achieved a sustained fusion reaction. This revolutionized energy production on Earth. It also opened the door to interstellar travel. The energy source of the stars was now within our grasp. We could finally build a spacecraft capable of reaching another star system within a human lifetime. The development of fusion propulsion was a pivotal moment in human history. It marked the beginning of a new era. We were no longer confined to our own solar system. The stars were now within our reach. The dream of interstellar travel, once relegated to the realm of imagination, was finally becoming a reality. The selection and training of the Alpha Centauri crew was a meticulous process, one that required an extraordinary level of precision and dedication. This was not just any mission, it was humanity's first step towards interstellar travel. It was a global endeavor, a testament to the spirit of international collaboration that had made the mission possible. Scientists, engineers, and astronauts from all corners of the globe came together, united by a common goal. The search for the first interstellar voyagers was a global undertaking. Each country contributed its best and brightest, ensuring that the crew would be a microcosm of humanity itself. The most brilliant minds, the bravest souls, were sought after. The selection process was rigorous, involving multiple rounds of testing and evaluation to ensure that only the most capable individuals were chosen. They had to be pioneers, explorers, and ambassadors of humanity. These individuals were not just astronauts, they were the face of our species, representing the hopes and dreams of billions. The ideal candidates possessed a unique combination of skills. They were brilliant scientists, skilled engineers, and experienced astronauts. Their expertise spanned multiple disciplines, from astrophysics to engineering, biology to geology. They were also individuals of extraordinary courage, resilience, and adaptability. The challenges they would face were unprecedented, requiring a level of mental and physical fortitude that few possess. They would face the unknown, the challenges of deep space travel, and the responsibility of representing all humankind. The vastness of space, the isolation, and the potential dangers were all part of the journey. Their training was as rigorous as it was comprehensive. It was designed to prepare them for every possible scenario, from the mundane to the catastrophic. They spent years preparing for the mission. Physical and psychological conditioning, language and cultural studies, and simulations of every conceivable scenario filled their days. They learned to work as a cohesive unit, understanding that their survival depended on their ability to function as a team. Simulations of every conceivable scenario filled their days. They trained in virtual reality environments that mimicked the conditions they would face in space, from zero-gravity maneuvers to emergency protocols. They were trained to handle the spacecraft, conduct scientific experiments, and deal with any emergencies that might arise. Their training covered everything from piloting the spacecraft to conducting complex scientific research. They were prepared to deal with any emergencies that might arise. Whether it was a technical malfunction or a medical emergency, they had the skills and knowledge to handle it. They understood the weight of their mission. The responsibility they carried was immense, knowing that they were the pioneers, the trailblazers, venturing into the unknown on behalf of all humanity. They were the pioneers, the trailblazers, venturing into the unknown on behalf of all humanity. Their journey was not just a scientific endeavor, but a testament to the indomitable spirit of human exploration and discovery. Section 4. Farewell, Blue Planet, Departure and the Vast Emptiness Ahead. The day of the launch arrived. The culmination of years of preparation, training, and anticipation had finally come to fruition. The air was thick with a mixture of excitement and anxiety as the final countdown began. It was a global event. People from every corner of the world tuned in, their eyes glued to screens, their hearts pounding in unison. This was not just a mission, it was a moment that united humanity in a shared dream. Billions around the world watched. Families gathered in living rooms, friends huddled in bars, and strangers stood side by side in public squares, all sharing in the collective anticipation of this historic event. They held their breath as the Ares, humanity's first interstellar spacecraft, roared into the sky. The ground shook, and the air was filled with the thunderous sound of engines propelling the spacecraft upwards, breaking free from the bonds of Earth. It was a moment etched in history, a defining point that would be remembered for generations to come, symbolizing the relentless pursuit of exploration and the indomitable human spirit, the culmination of centuries of dreams and decades of tireless work. Engineers, scientists, and visionaries had poured their hearts and souls into this mission, and now their efforts were being realized in the most spectacular way. As the Ares ascended, leaving Earth behind, it carried with it the hopes and aspirations of an entire species. The blue planet grew smaller, a reminder of the home they were leaving behind and the new frontiers they were set to explore. The initial days of the journey were filled with a mixture of excitement and trepidation. The crew, a diverse group of highly trained individuals, adjusted to their new environment, floating in zero gravity and getting accustomed to the routines of space travel. The crew conducted final checks on the ship's systems. Every switch, every dial, every piece of equipment was meticulously examined to ensure everything was functioning perfectly. Their lives depended on the reliability of these systems. They marveled at the shrinking view of Earth. The planet that had been their home, their cradle, was now just a small dot in the vastness of space, a poignant reminder of their origins. Their home, a pale blue dot against the backdrop of the cosmos. It was a humbling sight, a visual representation of the fragility and beauty of their world, now left behind as they ventured into the unknown. They were acutely aware that they were venturing into the unknown. The vast emptiness of space stretched out before them, filled with both infinite possibilities and unimaginable dangers. They were leaving behind everything they knew. Friends, family, the familiar comforts of Earth, all were now memories as they embarked on this unprecedented journey. Ahead lay the vast emptiness of interstellar space, a void that was both daunting and exhilarating, promising new discoveries and challenges that would test the limits of human endurance. The journey to Alpha Centauri would take decades. It was a voyage that required not just advanced technology, but also immense patience and resilience from the crew. It would be a test of human endurance and ingenuity. The crew would need to rely on their training, their intellect, and their ability to work together to overcome the challenges that lay ahead. Yet, they were undeterred, their spirits soaring with the knowledge that they were making history. They were pioneers, the first humans to venture beyond the confines of their solar system, driven by a shared sense of purpose and destiny. They were the first humans to embark on a journey to another star system. Their mission was not just a scientific endeavor, but a testament to the boundless curiosity and unyielding determination of the human race. Section 5. Life in the Void, Routine, Wonders, and the Challenges of Confined Existence. Life aboard the Ares settled into a routine. The crew worked diligently, conducting scientific experiments. They monitored the ship's systems and exercised to combat the effects of prolonged space travel. They remained in constant communication with Earth. They shared their findings, their experiences, and their hopes for the future. They celebrated birthdays and holidays, milestones in their extraordinary journey. They witnessed the awe-inspiring beauty of the cosmos, nebulae painted across the void, distant galaxies like swirling whirlpools of light. They saw the universe in its raw, unfiltered splendor. They conducted groundbreaking research. Their findings beamed back to Earth, expanding our understanding of the cosmos. They encountered challenges, both expected and unforeseen. The vastness of space was humbling, at times daunting. There were moments of tension, of isolation, of longing for home. They relied on each other for support, their camaraderie a beacon in the darkness. They persevered, driven by their mission, their curiosity, and their unwavering belief in the importance